Hi friends, in this video we are going to discuss about effect of prime mover input when excitation is constant. This is also same the parallel operation of alternator with bus bar at loaded condition, effect of prime mover input. Now here excitation constant. Let's see now. For example, this is our EMF and see, for example, alternators are in generally required to operate at lagging loads, right? So, for example, this is my initially at normal condition IA1. This is normally condition IA1. Then after prime mover input increases or load increases. When load increases, again IA increases. For example, this is IA2. Still increases. This is IA3. Again increases. This is IA4. Again increases. This is IA5. When the load and prime mover inputs are increases. So nothing but initially it is operating at lagging, then after unity power factor, then after leading. Here this IA1, nothing but initially at normal load condition is less than, IA2 is less than IA5. Nothing but when the prime mover input increases, the current is increasing. Nothing but this is goes from lagging load to the leading load. This is goes from lagging load to the leading load. Nothing but here armature current increases as well as power factor also changes. When the armature current increases, actually when the prime mover input or the load increases, then the armature current increases. We know that. When the load increases, load angle also increases. When the load or armature current or the power increases, power also increases. This is the common point for lagging and leading for motor and generator. What is the common point here? When the prime mover input increases or load increases, IA increases, load angle increases, and the power increases. Next, what happened to reactive power and what happened to power factor? These two are very important in this concept. In generally, lagging nothing but overexcited, leading nothing but underexcited. Yes or no? This is demagnetization effect of armature reaction, and this is magnetization effect of armature reaction. Here the reactive power is delivered actually, but here the reactive power is observed actually. So now tell me, for lagging load, what happened? Listen carefully. In lagging load, nothing but in this area, when the prime mover input is increases, then what happened? Of course IA increases, of course I know. What happened to power factor? When the prime mover input increases, the power factor is also increases, because from lagging to the unity power factor, from lagging to the unity power factor getting nothing but when the prime mover input increases, the power factor also increases. That's why here the power factor is directly proportional to prime mover input. First thing. What happened to reactive power? What is reactive power for lagging? Q delivered. So now tell me, what happened to reactive power when the prime mover input is increases? What happened to reactive power? In first case, I said that the power factor is directly proportional to prime mover input. And in next case, what happened to reactive power? What happened, sir? Tell me. When the prime mover input is changes nothing but from lagging to unity power factor, it is Q delivered, but here no delivered. So it is the delivering of reactive power decreases. Delivering of reactive power decreases nothing but when the prime mover input is increases, then the delivering of reactive power decreases nothing but this is inversely proportional to each other. So in lagging load of alternator, the power factor is directly proportional to prime mover input, but the reactive power is inversely proportional to prime mover input. This is very important concept here in lagging. Okay, sir, you completed in lagging. This part is completed. What happened for leading? What is the process in leading load? So let's see here in leading load. When in leading load from unity power factor to leading, when the prime mover input increases, the currents are like this, IA4, IA5. Nothing but this is also changing from unity power factor to leading. Nothing but when the prime mover input is increasing, what happened to power factor? Here from unity power factor to leading, nothing but the power factor is in decreasing manner. So in leading load, the prime mover input is inversely proportional to power factor. Is the one thing. What happened to reactive power? When the prime mover input is changing, then the reactive power. Actually, here the reactive power is 0, but here the reactive power is observing. Here no observing, here observing. Nothing but the prime mover input is directly proportional to Q observed. These are the 4 points you should remember for lagging 2 points and for leading 2 points. Other than that, you should remember another 3 points. One is the armature current and load angle and power. These are common for lagging and leading. For motor and generator, I said you already. But here you have to remember only power factor and reactive power. You should remember this. They will ask you questions. How they will ask you questions? For example, give me one question. An alternator operating in lagging load, if prime mover input or load decreases, then what happens? Alternator operation in lagging load, if the prime mover input or load decreases. When the prime mover input or load decreases, armature current decreases, load angle decreases, and power decreases. These are the common points I said you already. Now what happened to power factor? This is in lagging load. In lagging load, when the prime mover input decreases, power factor also decreases. When the prime mover input decreases, what happened to reactive power? Q delivered increases because of in inversely proportional manner. Like this, they will ask you question on load, effect of prime mover input or load. Is it okay? Clear? So this is also very important for competitive examination, right? Parallel operation of synchronous motor with bus bar at loaded condition, and what is the next part here? Effect of supply input or load, effect of supply input or load when the excitation is constant. This is important. We have to discuss about this one now. Here also same. For example, this is a EMF E. Is it okay? So when generally synchronous motors are operating in leading load, for example, my synchronous motor is operating in general condition, this is IA1. Then load increases or supply input increases, nothing but this is IA2. Again increases, this is IA3. Again increases, this is IA4. Again increases, this is IA5. These are the different load currents when load increases or supply input increases. Nothing but I said you one is the common factor when the supply input or load increases, then automatically IA increases, load angle increases, power increases. This is the common factor for all, for lagging, leading, and for motor and for generator. But now let's see here, when the load increases, actually this is leading load and this is lagging load. Nothing but this is goes from leading to lagging. In between unity power factor is there. Actually here lagging nothing but under-excited, leading nothing but over-excited. Here Q observing and here Q delivering. Here magnetization and here demagnetization. Right. When the supply input or load increases, what happened here? Let's see. Right. First for leading load. For leading load, when the load increases, then automatically IA increases, of course. Load or supply increases, then what happened to power factor? When the load increases, this is flows from leading to unity power factor. Nothing but the power factor is directly proportional to load. This is very simple, right? Yes or no? Next one, what happened to reactive power? Can you tell me what happened to reactive power when load changes? When the load is changing here, see, here is Q delivered, but here Q is 0. Here is Q delivered, but here is Q is 0. Nothing but Q delivered decreases. Q delivered decreases, nothing but the reactive power is inversely proportional to load in leading loads. This is simply about the leading load. So what is the answer for lagging load then? Let's check it here for lagging load. Even in lagging load, here in this condition, when the load increases, it goes from unity power factor to lagging. Nothing but the load is, tell me, directly proportional to power factor or inversely proportional? From unity power factor to lagging, nothing but the power factor decreases, nothing but inversely proportional to power factor. Is it okay? Next, what happened to reactive power here? Here the reactive power is 0, but here observing is more. Here Q observed, but here Q is 0. Nothing but what happened here? Here the load is directly proportional to reactive power, because here when the load increases, Q observing increases. This is the concept for the parallel operation of synchronous motor with bus bar when the supply input or load increases. How they will ask you question on this? For example, a question: synchronous motor operating at leading load, if supply input reduces, then what happened? If supply input reduces, then what happened? When this supply input reduces, automatically IA reduces, load angle reduces, power also reduces. We know this is the common point. But what is the uncommon point here? When leading load, if supply input increases, power factor reduces. When supply input reduces, power factor reduces, but Q delivered increases. This is what the reactive power and power factor very important in this concept. So finally, what is the conclusion here? Let's see. I said you already, for motor and generator everything is same, just changes are there. There is no much changes actually. So let's see here, check it. This is for alternator and this is for motor. When two alternators operating in parallel with load, effect of prime mover input. Here we have a lagging load and leading load. Here we have a lagging load and leading load. Here the prime mover input is directly proportional to power factor and the prime mover input is inversely proportional to Q delivered. This I said you in alternator lagging load. But in this motor, the supply input or load is directly proportional to power factor. Yes or no? And here the load or supply input is inversely proportional to Q delivered. Everything is same here. This is overexcited. This is also overexcited. Overexcited. This is simple. And this is underexcited. This is also underexcited. Just lagging is leading, leading is lagging. Here what happened? The prime mover input is inversely proportional to power factor and the prime mover input is directly proportional to Q observed. Right? This is very simple. Whereas here, this is here, the supply input or load is inversely proportional to power factor. The supply input or load is directly proportional to Q observed. Very simple. The lagging is leading, the leading is lagging. That's it. This is the parallel operation of two alternators, which is connected to infinite bus bar with loaded condition. Are you getting or not? Of course, this is effect of prime mover input or supply input. Effect of excitation, very simple. In effect of excitation also, just V curves and inverted V curves, they will ask you a question on that. The V curves are drawn between field current and armature current. Inverted V curves are drawn between field current and power factor. Commonly, I am telling you, commonly for generator and motor. In generally, excitation increases or excitation decreases, whatever it may be for motor and generator. In both the cases, if excitation increases or excitation decreases from normal value, in both the cases, the power factor is decreases and the armature current is increases. Simply, I said you already, the armature current is inversely proportional to power factor because Ia cos pi is a constant in effect of excitation. This is effect of excitation. This is effect of supply input or prime mover input. The totally, when the synchronous machine, nothing but motor or generator connected to infinite bus bar with loaded condition, this is only. You should remember easily, but you should make it a short notes. Otherwise, you won't get this one. You get confused. Many questions are there. Many questions we can make from this concept. So, be careful. Just listen carefully and see the videos again and again and write the notes clearly. Then you can get the answer. Right? Thank you.